Hi all. Today we are going to see about fundamentals of algorithm problem solving in design and analysis of algorithm. This is the basic structure for fundamentals of algorithm problem solving. First one is that understand the problem. Next one, decide on computational devices. Next, select between exact and appropriate algorithms. Next, algorithm designing techniques. Design an algorithm, prove the correctness, analyze the algorithm, and code the algorithm. We'll see everything in detail. First one, understanding the problem. The basic thing in algorithm problem solving is that we have to understand the problem completely. That is, we have to read the problem's description carefully and ask the questions. If you have any doubt about the problem, do some few examples by hand, think about the special cases, and ask some questions again if needed. Next, it is the capabilities of computational devices. The capabilities of computational devices comes under two different steps. It has been solved using two different methods. First one, it has been solved parallelly, and next one it is paired one after the other. The problem that has been solved parallelly, it is called as a sequential algorithm, and the problem that has been solved one after the another using one operation at a time, that is called as RAM, that is a random access machine. Next one, choosing between the exact and approximate problem solving. To solve a problem, it is not a compulsory that we have to find a new solution. The solution has already been defined. We have to select between exact algorithm and the approximation algorithm. That is, if you have to solve a problem, the solution will be already defined. We have to use some algorithm which is already defined. In that cases, we have to choose the best algorithm to solve the problem. In case of choosing the best algorithm, it is called as an exact algorithm, or in the later cases, it is called as an approximation algorithm. Next one, it is the algorithm design techniques. There are several designing techniques where an algorithm can be solved. It has been solved using divide and conquer method, brute force technique, dynamic programming method, and more. Next, designing an algorithm. There are three main options for specifying an algorithm. First one, it is a natural language. A natural language, it means that the language which we speak in common, maybe in English. Next, it is a pseudocode. Pseudocode, it is a mixture of a natural language and the programming language. That is, it is combined both the normal language as well as the programming languages like C, C++, Java, using some algorithm techniques. Next one, it is a flowchart. Flowchart is that solving the problem using a structural format, that is using some structures like connected geometrical shapes, and that structure we call it as a flowchart. Next one, proving the correctness. Proving the correctness, that means once an algorithm has been specified, you have to prove its correctness. That we have to check whether the program given is correct or not. That is, you have to prove that the algorithm yields a required result for every legitimate input in a finite amount of time. Next one, analyzing the algorithm. Analyzing an algorithm is the most important thing, that is efficiency. There are two different kinds of efficiency. First one, it is called the time efficiency, and next one is the space efficiency. Time efficiency means that the amount of time taken to solve a problem, that is called as a time efficiency, and the amount of space that has been required to solve the particular problem, it is called as a space efficiency. Based on these two efficiency, the problem will be considered whether it is efficient or not. And the final step is that we have to code an algorithm. Code an algorithm, it means that once the problem has been specified and it has been verified and it has been analyzed, we have to solve the problem we have to complete the problem using any programming languages like C, C++, Java. That means that the coding of an algorithm. These are the main steps that comes under the fundamentals of algorithm problem solving. And thank you for the session. Thank you.